Welcome, guys. So let's solve in this 2037 minimum number of moves to see everyone. To see as to seat, not to see. Okay. So there are seat and student in person room. Oh, hope you guys subscribe to my channel. So you are given a rate seat of length n, where is the position IC. You're also given a rate student length n, where student J is the position of J. Okay, so you can increasing a position I student by 1 and return a minimum number of moves required to move each student to a seat such that no student are in the same seat. Okay, so this example, very easy. So you get 315, which is the seat, and the student is 274. Okay, so I mean, I guess the first student at the 2, right, can move to the position, move to a position 1. So 1 move, and student 7, originally 7 position, or student S7 should move to 5, which is 2. Then the student 4 should move to 3, which is 4, 1, right? So total is 1 plus 1 plus 2. Okay, so this problem is simple, right? Suppose I sorted our seats. So we will count 1, 3, 5. So this is the seat, and I sorted the students, which is 4, 7. Then I compute its difference, so which is just 1, 1, 2. So answer will be 4. Okay, so the algorithm should be easy, right? So you first sort your seat and sort your student, and then compute the absolute value of its difference. And because you know that the length of the seat and the student are the same, so you just calculate its difference. Okay, so compute the length and sort it both, and the answer initially by 0, and then you just calculate the difference, and this will be the answer. Okay, so for example, let's quickly go through this example so that you will believe why I say it's true. Okay, so you first sorted seat, you get 1, 4, 5, 9, and then you sorted the student, you get 1, 2, 3, 6. So the difference is 0, 2, 2, 3. So the answer will be 7. Okay, that's it. Okay, see you guys next videos.